So this section 4 that we'll talk about today is about increasing, decreasing, and constant, as well as extrema. That's not spelled right. That's better. So, when we talk about increasing, decreasing, and constant, what I mean is the increasing parts is where the graph is uphill. The graph is going uphill. Decreasing, what we mean is where the graph is going downhill. And constant is where the graph is flat. And by extrema, we're talking about either the top of the hill or the bottom of the valley. So, the important thing to remember when I say uphill, downhill, flat, etc., is that we're always talking about reading our graph from left to right, just like you'd read on a sheet of paper, or you'd read a book. So if I look at an example, let's say we look at this example. We're going to determine the parts that are increasing, decreasing, and constant. If you remember last year that we talked about the way to think about this is imagine your little man is walking along the graph. Let's give our little man a name. I'm going to call him Hans this year. He's a good Swiss mountain climber. So Hans is walking along our graph. So he starts off on this left arrow, and he walks uphill all the way to -4. Everybody agree with that? So this section here, he'll be walking uphill. Once he gets to this section is flat. And then when he gets to this section, he's going downhill again. Everybody agree with Hans's trip there along our graph? Okay. So this section that is uphill, this is increasing. The section here that's flat, that's the constant section. And this part that's downhill is our decreasing section. Does that make sense to everyone? Just visually picking these out? So typically, we would want to describe where the graph is increasing, decreasing, and constant using an interval. So this first section that's increasing, we start at the left-hand arrow, that's -infinity, and we end here at -4, where the graph changes from uphill to flat. Everybody agree with that? Now the infinities always get a parenthesis, and the transitions, where we go from increasing to decreasing to flat, are also always going to get a parenthesis. Now we're on the constant part. So notice we're starting the constant part here at -4, and we're going all the way, staying flat to that point there at +3. Everybody okay with that idea? Again, the -4 is at a transition from increasing to increasing to constant, so it's going to get a parenthesis. And the 3 is at a transition from flat to decreasing. We'll also get a parenthesis. Now let's do the decreasing segment. That segment starts at 3 and goes all the way to the right arrow, which would be positive infinity. So the 3 is a transition from flat to downhill. That gets a parenthesis. And the positive infinity always gets a parenthesis. Everybody okay with this idea? Let's do another example. Sound good? Okay. What if I give you, instead of a graph, an equation? What would be the first thing you'd want to do here? Put it in your calculator and graph it, right? That's what I would do first, because if I have the picture, it's not too bad figuring out these intervals of increasing, decreasing, and constant. So I'm going to take out my graphing calculator, go to the y equals menu, clear out whatever stuff that might have been in there, and I'm going to type this in exactly as it's written. So the easiest way to type in a fraction is to use the fraction commands. You can access the fraction commands by pressing the alpha button and then the y equals button. The fraction command we want to use in this case is the numerator over denominator. Alpha and then y equals opens the fractions menu. And then I pick the numerator over denominator option, which is the first one. And it'll give you a little fraction bar, and now we can just type it in exactly as it's written. Much easier to type this part in without making an error than to try to use parentheses to type this in. You have to be a little bit careful to use the division sign and parentheses. You need to make sure you have a parenthesis around the entire numerator and the entire denominator. Which is sometimes easy to forget to do. Everybody happy with this? So let's graph this. I'm just going to graph it by doing zoom standard. I was hoping that would work a little easier. No. Darn it. I was hoping I could just embed that screenshot. I wonder if I just drag it in here. Will that work? Booyah, that worked. That's mega easier. Okay. Look at that. It's pretty slick. All right. So, increasing, decreasing constant. How many increasing parts do you see? I see 2 as well. So one of them is this part. Hopefully everybody sees that. That's easy to see that's increasing. The second increasing part is that part. Everybody agree with that? How many decreasing parts do you see? I also see 2. So this part on the far left, right. Left and right is hard, guys. And then one part here. Everybody agree with that? Do you see any constant parts? No, I don't either. Everybody okay there? Now I want to point out that I get that it's tempting to say, aren't these parts flat? You know that they're really not, right? That this is still kind of decreasing. We just are so far zoomed out that it doesn't appear to be flat. Just because of the nature of the calculator screen, like it has only so many pixels. So it can't really show that that thing is actually getting, or still decreasing, or increasing in those sections. Okay, so let's write our intervals of increasing. So we'll start with the first interval here, because it has 2 increasing parts. I know it's going to have 2 intervals that I'm going to have to group together with the union symbol. Similarly, for the decreasing part, I know I'm going to need 2 intervals connected by the union symbol. All I need to do now is to fill in the upper and lower bounds for these. Everybody okay with that idea? So let's look at this first increasing part here on the left. I'll start with the leftmost part of it, which is an arrow pointing to the left. What should I pick as my lower bound then? Negative infinity. And where does this increasing part look like it's stopping? Well, that's the y-coordinate, is where does it look like it's stopping. I care about the x's. It kind of looks like it stops there. Don't you agree? So we'll do -3. Does that make sense to you guys? Always remember, when we write these intervals, unless we're talking about the range, we're always talking about x's. The range is the only time we talk about y's when we write an interval. Everybody's okay with that? All right. Now let's look at, so we did this part. Now let's look at this other increasing section. So the beginning starts right here. Everybody agree with that? Where is that starting at about? Still looks like about -3. Everybody agree? And then where does it finish up at? 0. So we've done that part. So far, so good? Questions yet? Pace is okay? Not going too fast? Okay. Let's look at the next decreasing segment. So that starts here. So what x value is that? 0. And it ends about here. What x value is that going to be about? +3. So we're done with that section. We'll look at the last decreasing segment. The beginning of it starts here. That's about what x-coordinate? 3. And it ends here at the very far edge of the graph. What's that really mean? Yeah, positive infinity, or just you could write infinity without the plus sign. That's fine for the positives. Everybody okay with that idea? This feels manageable, I hope? Okay. So again, all we have to be able to do is read the graph and identify when it's going uphill and downhill, and be able to translate that information in using an interval notation to describe when it's doing uphills and downhills, or where, I should say, it's doing uphills and downhills. So the other part of this topic we need to talk about is the extrema part. So there's two kinds of extremas. There's maxima. That's the plural for the word maximum. And then there's minima. That's the plural for the word min. So for both maxima and minima, there's two types of those. You can have a local, and then you can have the absolute, or sometimes we say the global. Those two words get used kind of interchangeably. So the global is the highest, let's say maybe the global max is the highest point. And the global min is the lowest point. The locals are any max or min. So we'll draw some pictures and do some examples and talk about the difference between a local and global. But it's not too bad once you have seen some examples. It's much easier to explain in a picture than it is in words, to kind of show you what's a local and what's a global. Okay? So let's look at this graph here. How many extrema do you guys see? So again, extrema is the generic term for a maximum or minimum. I see 3. Does everybody see 3? I see 1 here, I see 1 here, and I see 1 here. So we'll just kind of go through. This one on the left, is this a maximum or minimum? That's a maximum. This next one in the middle is a minimum. And the last one is a maximum. Everybody agree with that? Okay. Is the first one a global maximum or a local maximum? This is a global. Why is it global? Because that is the absolute highest point on the graph. You could also write absolute maximum. I think global is like 2 less letters, so I'm going to use that term because it's less writing. And yes, I am that lazy that I'm concerned with writing 2 less letters. Let's look at the middle one. Is the middle one a local or global? It is local. Why is it? Because all of these points are lower than that minimum, are they not? So notice I didn't say it was the lowest minimum, it was the lowest point. So if I have arrows if I have one of my arrows that points down, cannot have a global minimum. This is just a local. Everybody okay there? That's a little sneaky, but now that you've seen it, you know to watch out for it. And the third point here, is this local or global? Local. Everybody feel pretty decent about this? Okay. So it's usually easiest to kind of pick out whether it's local or global by just looking at it with your eyes. To find the actual coordinates for these is very difficult to do algebraically, and it's beyond the expectation of this course that you could do that algebraically. I would expect you to be able to use your calculator to do this. So let's do a quick example of how do we use our calculator to find these maxima or minima. So I'm going to graph the function x to the fourth plus 2x to the third minus 4x squared minus 3x plus 1. So that was x to the fourth plus 2x to the third minus 4x squared minus 3x plus 1. I'll just graph that on the standard window. So I see one global minimum, one local maximum, and one local minimum. Everybody agree with that? To find the coordinates here, for this minimum, say, I'm going to press second and trace. If I'm looking for a minimum, I should use the minimum command. So I'll select command 3. And now notice at the bottom of my calculator, it's asking me a question. It asks me for left bound. So see the cursor that's also flashing on the screen? What I need to do is I need to move my cursor somewhere left of that minimum and then press enter. So I'm just going to use the left and right arrows, in this case the left arrow, to move that cursor somewhere left of that minimum. That looks good to me. I'll press enter. Almost anywhere to the left is going to be fine. Now the question is changed to a right bound.
As we come to the end of our last period, we call upon our God, the Father, the Son, and the Holy Spirit. Amen. Is there something that I would like to ask God's forgiveness for? Something I said or did, or maybe hurt someone? God of all compassion, we praise your goodness to us and to everyone. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Hold on real quick.
In the high school especially, if there's anyone who has forms to hand in, emergency cards or anything else, bring those down to the office. Teachers, you can dismiss students as you're ready.
Hold on. So then it changed to right bound. I moved my cursor to the right of where I was looking for. I press enter again. It says guess. I can just press enter again. And it spits out that the minimum is the point negative 2.24. And then the y-coordinate is negative 0.65. Okay? I'll post your assignment to PowerSchool. Check when you get home. Okay, guys? Thank you.